Lesson 30. We're looking at arithmetic sequences and series. Now, I say arithmetic. You could also read it as arithmetic sequences and series, but for me, that just doesn't flow off the tongue as well. In this section, okay, there is a very particular kind of sequence and series we're talking about, and it has this particular property right here, where the next term minus the previous term is equal to some value d for all positive integers I. So this is for every single term. What that really means is, the number d is considered the common difference. Okay, the common difference. Well, if it's common difference, that means that every single term in the sequence has a specific value added to this term to get to the next term. If you move this thing over, if you add ai to both sides, you get ai plus d is equal to ai plus 1. So what we're saying is that every single term, you're adding the same number to get to the next term. So let's go ahead and look at the examples. Example number 2 says write out 2 different arithmetic sequences and an example that is not arithmetic. Now I'm going to do this on a separate piece of paper. In terms of 2a, an arithmetic sequence, a series might look something like this. Let's just go 0, 2, 4, 6, 8, 10, ... You notice every single time from here to here, I added 2. From here to here, I added 2. From here to here, I added 2. What's my common difference? My common difference is 2, okay? And I happen to start at 0. I happen to start at 0 and add 2 to that to get to 2, and so on and so forth, okay? So this is an arithmetic sequence. I'm adding the same thing every time, okay? How about 2b? Let's start instead at 36, and I'm going to change it to 30, and then 24, and then 18, and then 12, and so on and so forth. Now, it might not look like I'm adding the same thing every time, but think of it as though from here to here, I subtracted 6, which is really adding a negative 6. From here to here, I've added a negative 6. From here to here, I've added a negative 6. So I am adding the same number every time. There's nothing stopping me from using a negative number. Again, in this case, my difference is actually a negative 6. Not positive, a negative 6. And then 2c, the last case, something that's not arithmetic. Well, if I did something like this, let's do 25 goes to 20, goes to... let's see here. Let's do 21, and then 16, and then 17, and then 12, and then 13. Now you might recognize the pattern as I was creating it. Okay, it's obvious that from here to here I subtracted 5, or in other words, I added a negative 5. From here to here I added 1. From here to here I added that negative 5 again, then a positive 1. Then a negative 5, then a positive 1. Now, this appears to be behaving in a adding or subtracting the same thing almost every time. But the issue is this is not arithmetic. We don't have a common difference. Okay, we have negative 5 for some of the terms and a positive 1 for some of the others. So this is not arithmetic. Okay, again, this is just considered a sequence. Yes, it's always behaving in an addition or subtraction fashion, but it's still not arithmetic, okay? Looking at number 3, the nth term of an arithmetic sequence with common difference d is given by this. Now, what's wonderful about this entire section is that if you see the addition occurring every time, or even better, they tell you that you're playing with an arithmetic sequence, this right here is the formula for finding any nth term, okay? So, I'm going to go ahead and use that formula in the next couple of examples. It says, for number 4a, find the nth term of the arithmetic sequence, find the 25th term. So I want a sub 25. Again, the 25th term, a sub 25, of the sequence whose first 3 terms are, now the a sub n is actually equal to negative 12, negative 6, 0. So, for me to be able to solve this, I'm going to go ahead and write down the formula. A sub n is equal to a sub 1 plus n minus 1 times the d. Okay? Let me zoom this out just a little bit so you can see it all. Now, when I've got something like this, the first thing I want to do is go ahead and find out the pieces I need. Well, from here to here, it looks like I've added 6. Let me just do the second step to make sure. Yes, I've added 6 there as well. So the d value is 6. Okay, that's my common difference. And then I'm going to have, well, I want to find a sub 25. So everywhere I see an n, I'm going to replace it with 25. So I have a sub 25 is equal to a sub 1. I don't know what that is yet. I didn't find it. 25 minus 1, and then times the 6. What's my a sub 1? Well, that is the first term in the sequence. So I'm going to go ahead and plug that in. I have a negative 12 plus, this is going to be 24 times 6, whatever that number happens to be. I'm going to go ahead and do that in a calculator real quick. 24 times 6 is 144, and then I'm going to add a negative 12 to it. This is a 132. Okay, so this would be the 25th term in the sequence. So I have the first, second, third, and then if I count all the way through, it's very easy for me to find the 25th term with this formula right here. Okay, this formula you're going to want to keep close by. For 4b, this is the 15th term, so I want a sub 15 of an arithmetic sequence is negative 3. So they told me that this was equal to negative 3. And the first term, a sub 1, is 25. They want me to find the 10th term, a sub 10. Okay, so with all this information, there's quite a bit of stuff going on. We might want to go through these details very carefully. Now, first of all, these two pieces of information are absolutely necessary for me to find out what a sub 10 is. But before I can do that, I'm going to have to find the difference, right? I'm going to have to find the difference. So what I'm going to do is I'm going to say a sub 15 is equal to something. What's it equal to? Well, it's supposed to be equal to a sub 1 plus our n value being 15. So 15 minus 1 times the common difference. Now, what is a sub 15? A sub 15 is a negative 3, so I'm going to replace that with a negative 3. A sub 1 is 25, so I'm going to replace that with the 25. And then you'll notice I have a formula to find d, or I should say an equation to solve for d. So I'm going to subtract 25. That's going to give me a negative 28 is equal to 14d. I'm going to divide both sides by 14. Okay, and that's going to give me, let's see here. Yeah, that's going to give me a negative 2. So d is equal to a negative 2. Now, if I've got d as negative 2, what I'm going to have to do here, okay, is take this number with this knowledge over here to find a sub 10. Well, what's a sub 10 supposed to be? A sub 10 is supposed to be the first term plus 10 minus 1, again using the formula right here. N is 10 minus 1, and my d value is a negative 2. What's a sub 1? A sub 1 is 25, so that means I'm going to have 25 plus, this is going to be 9 times a negative 2, which means I have 25 minus 18. Their value is then going to be 7. Okay. Now, you'll notice something quite interesting about all of these terms. What are we adding or subtracting every time? A value of 2. But notice, my first term is 25, my 15th term is negative 3, my 10th term is 7. All of these numbers are odd. Well, if I start with an odd number and I always add or subtract a value of 2, I'm going to end up with an odd number. It's going to jump all of the even ones. That's a good thing to keep in mind in terms of number sense for future classes. That takes care of 4b. Let's go ahead and keep moving and talk about arithmetic series. So, S sub n is called the nth partial sum of the infinite sequence. Again, the nth partial sum of the infinite sequence. So, what we're doing here is I am adding up. S sub n is adding up the first n terms of the sequence that I was given. Sequence a sub n. I'm adding up the first 1, 2, ... all the way up to the nth term. That's what the partial sum S sub n is. Again, it's a partial sum because it's not all of the terms. All of the terms would be S sub infinity. Okay? Now, the nth partial sum of an arithmetic sequence is this. Oh, that's real nice. Once I've given you a sub 1, a sub n, and how many terms I want you to add up, you can simply plug it into this formula. Okay? Another formula for that is this. Now, this formula right here actually is derived from this one, noticing that a sub n has a specific formula, okay? Now, let me very quickly go through that. I'm going to actually go ahead and determine how we get 7. We have 7 formula from 6. Okay, now, the formula that I'm starting with is number 6, and that's n over 2 a1 plus a sub n. Now, how do I get to the other formula? Well, I get to the other formula by remembering that a sub n is actually equal to a sub 1 plus n minus 1 times d. Let me go ahead and take this thing here and substitute it in for a sub n. So that gives me n divided by 2 times a1 plus n minus 1 times d. Well, if I have two a1s, what is that really? N divided by 2, 2a sub 1 plus n minus 1 times d. And you'll notice, if I put those in brackets, that thing is exactly the same as this right here, where I take this division of 2 and I just force it to be over everything here. Okay? So that covers the formulas 5, 6, and 7. Let's talk about example 8a, I think, in the next... no, we'll do it right now. Why not? 8a. Evaluate the series I equals 1 to 100 of 2i minus 1. Okay. What I'm asking you for is, what is s sub 100? That's what I want to know. Okay. What are the 100 terms added up in this? Now, what we could do is we could go ahead and, write out all 100 terms. When I plug in 1 into this thing, I get 2 times 1 minus 1 is 1. Then I go ahead and I plug in 2 and I get 2 times 2 is 4 minus 1 is 3. And then plus, and I plug in the next one, I get 5, 7, 9, and continues on forever. You'll notice that all of these are the odd terms. This right here is the mathematical notation for odd numbers. Okay? Well, there should be an easier way to do this than, write them all out. Well, what would the 100th term be? What would a sub 1 be? A sub 1 is just 1. What's a sub 100? Well, if I plug in 100 here, I get 2 times 100 minus 1, which is really just 199. Okay? So now I have a sub 1 and a sub 100. Well, wait a second. I have formulas for this. S sub n is equal to n divided by 2 times a1 plus an. Well, if that's the case, that means that this thing should be equal to 100 divided by 2 times a sub 1 plus a sub 100. That's why I found both these terms. So what do I really have here? Well, this is going to be 100 divided by 2 times 1 plus 199. That there is going to be 200. So this is going to be equal to 100 divided by 2 times 200. Well, the 2 and the 2 can cancel out. I'll be left with 100 here. 100 times 100 is really just 10,000. That would be the sum of all of these odd numbers. That would be the sum of all of these odd numbers. I'm going to do 8b in the next video because I believe that one's going to take me a little bit more time than this one did.